Going to learn about the image tracing. We have few rules regarding the image tracing. First such rule is we have to use at least 2 rays to draw the image. Is the primary thing. We can use more than 2. If you use more than 2, what could happen? The final image appears to be confused one. Okay. Now, it is the image tracing in case of the concave mirror. Let's say it's the concave mirror, and know that the outer bulgy surface is silver or coated, and it is the principal axis, okay, which is passing through the center and joining the center of curvature. Now what I am doing, say it is the focus, I am dividing this thing into 4 regions. Okay. It's the first region, is the second, and is the third, and it is the fourth. I divide it is into 4 regions. If you watch it carefully, okay, in first region we keep the object and we observe the image positions. Later we come to the second region, it is in between C and F, and the third region, it is in between, okay, pole to focus, and the fourth region is beyond the mirror. Here, first what we are doing, keeping an object at infinity. That means we are keeping the extended object in the first region. I am drawing the same diagram here. It's the same concave mirror, and it is the principal axis. Okay, I said it is the focus, is the point on the principal axis where S will meet after the reflection, and it is the center of curvature. Now I am taking an extended object. Generally objects are classified into 2 types. One is the point sized object, and second is the extended one. Extended one is what? Which has measurable dimensions. I am taking a linear object here. Okay. Here imagine that we kept an object at infinity. Object distance is infinity, and you learn that the rays which are coming from infinity appears to be parallel to the principal axis. Here, let's say it is the ray which is coming from principal axis. Then we have to apply the laws of reflection. Actually, it is the normal, so it is the incident ray, and the reflected ray is the I, and it is R. I am doing the same here. First I am locating a normal. It is a normal. Okay. And what happens? The ray incident, okay, it gets reflected in this way. Let's say is the angle of incidence, and it is angle of reflection. As you know that for a regular or diffused or irregular reflection, for a regular or diffused or irregular reflection, angle of incidence is equal to angle of reflection. The ray comes here. In the same way, I told you we have to take a set of rays. One more ray I am taking right now. Here's the ray. And what did happen here? The same thing will happen. We have to connect this one. Okay, angle of incidence and they get reflected. The beat at a particular point. Here the image will form. Here it is the angle I and it is angle I. Here see, we are tracing the first we can. The object in the first region means what? U at infinity. We have to write the characteristics of that. If you watch it carefully, the first such character is the image is real. The image is real. The second one, the image is inverted. The third one, diminution. That means small. These are the image characteristics. When you keep an object in this region, it means what? U, object distance is infinity. I hope you understood this. If the object is kept at infinity, after reflection, rays will meet at the focus. Okay? That means image position is nothing but the position of the focal length. Focal length is coinciding with the image distance. You can understand this very well. If you apply the sign convention, you have to, what's that? You will learn how it is happening. Okay? Let us apply that. 1 by F is equal to 1 by U plus 1 by V, the mirror formula. And a concave mirror it is. Concave mirror. And it is the distance of the principal focus from the pole. That means we have to keep the negative sign, and we took object as at infinity. And what about the V? Do remember, when you are solving the problems or taking the equations, you should not keep the sign for unknown quantity. Here we don't know where the image will form and became the unknown quantity. That's why you should not keep any sign. But what happens here? It is 1 by F is equal to 1 by infinity plus 1 by V. Okay? Then it becomes V is equal to minus F. Negative sign indicates that the image is formed in front of the mirror. When the image is formed in front of the concave mirror, all the time it is real. If the final image is formed in front of the mirror, all the time it is the real. Keep that thing in mind. I think you understood. But the formation of the image, when the object is kept at infinity. Object at infinity means what? It is beyond the center of curvature. Okay? Then we go into the next segment. That means now we are keeping the object at center of curvature. This is a position. Okay? See this. Object at C. It is a classic example of image formation. See this, what could happen? The same concave mirror. And you have learned that it is the principal axis. and we have to locate a point which is set as a focus, and it is the C. We are taking an extended object and we kept its center of curvature. Now listen, to trace the image, all the time we have to take a light ray which is passing parallel to the principal axis, which is coming out from the head of the object. The same thing will happen here. It comes, and usual, we have to apply the loss, then it get reflected like this. Okay, then we have to take one more ray. Okay, which is the pole and reflects back to the same angle. As you know that what angle of incidence is this, and reflection should be okay. If I extended these rays, they meet at a particular point, and if you connect them, the image is exactly at the same position where we kept the object. That's why I said it's a classic case. Okay, I have to draw the line straightly. It's looking like the wires are hanging. It's not. You have to draw the straight lines. And observe that it is it is the incident ray, and we are applying, and we are learning what is happening here. Okay, and we are writing the image properties. As usual, the image is real at C, object at C. What's the nature here? Second, inverted. Third, but of same size of object. Same size of object. It means it is the image distance and it is object distance, and as well as the image distance. They are coinciding. That's why same size of the object. That means the magnification is 1. Okay. Sometimes in examination, the question will be asked like this: is there any possibility of the position of image is at the same position of the object, or is there any possibility of the difference of image distance and object distance is equal to 0? Simply you can say, when the object is kept at the center of curvature, the image will be formed at the center of curvature only. It means that the difference between the image distance and object distance is equal to 0. Okay, it's the second case. I hope you understood that. And we are coming to the next segment where we are keeping the object. I hope you understood, and you understood the image properties also. And now see the third. We kept the object in between See, in this case, we are keeping the object in between C and F, center of curvature and focal length. I'm going to do the same thing what I did before. The same concave mirror. principal axis. Okay, and we said it is the focus and it is the center of curvature. The object is kept in between. Let's see what happens. As usual, one ray proceeds parallel to principal axis. Okay, saying it as F. After reflection, it passes through the focus, and I am taking one more ray which is coming from the head, travel straightly, and is the pole, and reflected back with the same angle. If I extend them, the both will meet at a particular point. Okay, I'm drawing the wire diagrams. Use the scale. Draw the images. Okay. Okay. If I extend this one and say it is the object and get image here. If you watch it carefully, you will observe one thing. When you are moving towards the mirror, the image always moves away from the mirror. Keep that thing in mind. If you are moving towards the mirror, the image will move away from you. Then we'll write the image characteristics in between C and F. Okay, the same thing, routine I am doing. The image is real, inverted, a third one, it is enlarged. Okay, the size of the image has been increased. This is another case. In this one, what did happen? We kept the object in between C and F, and final image is formed beyond the C. It's a real inverted, but it is enlarged when compared to the object. Here you have to remember one thing. When you are approaching towards the mirror, the image will move away from you. And you can say, if you are moving away, then image will be near to that. This is the third case. And fourth one, say this object is kept at focus. Object is kept at focus here. Same. Now watch. It is the same mirror. Okay. Is the focus and is the center of curvature, and is the pole and the caret. An object here, let's say object. Usual things we are doing. One ray has to pass straightly. After reflection, it reflected back. And I am taking one more ray. Okay. It came an incident, and watch it carefully. It traces the same path, which appears to be parallel, and you extend this back. Okay. Then you will find they image at infinity. Okay, it is when you keep an object at the focus. These rays are parallel to each other. In basics, we have learned that two parallel rays always meet at infinity. It's the classic case. And you have to write the image characteristics. What's that? This case is at F. Okay? First now, here we will get what? The virtual image. What is the virtual and what is the real image and what is the real object and real image? I explained all those things in my previous videos. Please visit the video, you will find. Image is virtual. The second is a larger okay. Virtual image will form. Is a classic case. Okay, if you keep an object at focus, the image will be infinity. Is a virtual image. Then finally we are entering into one more section, that means what? The cat in between focus and pole. I hope you understood this. In between F and P. See now, it's the same concave mirror. And take it as the principal axis. Is the pole, say it is F and it is C. Right now we are keeping an object in between F and P. I have to do the routine. One ray has to go parallel after reflection. It has to come back. Okay. One more ray we are taking. Here the same routine what I am doing. I took it and it come an incident and it follows the laws of reflection. Okay. If you watch it carefully, what's that? The gap is widening. It is increasing. That means you cannot make them to meet at this point. You have to extend that back. Okay. Analyst back. The rays will meet at a particular point. Okay. The image is formed here at a particular distance. In previous case, it is formed at infinity when the object is kept at the focus. Here is beyond the mirror. Then we have to write the properties, the same properties. Okay. We will find where will be the image position. Okay. It is the image, is the object distance, and the final characteristics at or between F and P. Virtual. The second one, erect, and third one, magnified. Here the same thing will be applied here. It's also magnified one. Okay, it is the image tracing in case of the concave mirror. You watch it carefully. The image will form beyond. That means what you have to understand. When you keep an object at F at the focus, and as well as in between the focus and the pole, in these two cases only, we are getting the virtual images. In other cases, the image will be the real and inverted. And also one thing you have to remember, in all before cases, that means what, in the region 2 and 1, the images are real and inverted. Here in region 1 only, the images are erect and as well as the magnified, and they are virtual. I hope you understood the image tracing of a concave mirror. Again I am repeating, if you feel it is worth watching, please subscribe my channel. If it deserves, give me a like. If you have any queries about this, means any doubts, then freely you can message me. In next session, I will try to clear your questions. Thank you for watching my video channel.